Okay, this video is going to talk a little bit about reactions, some of the terms that you need to know regarding synthesis of polymers from their monomers. So if we're talking about any type of monomer, which is just a single unit or a building block, and like I did in class, I'm going to draw it as a rectangle. This is a monomer. This monomer could be a nucleotide. I'm abbreviating it as NT. To make nucleic acid, it could be an amino acid, so I'm putting AA. To make a protein, or it could be a monosaccharide. I'm just putting mono. Or it could be a fatty acid chain if we're trying to make a triglyceride. Okay, any one of these things, they all contain what are called hydroxyl groups. A hydroxyl group is a hydrogen and an oxygen together. So here's another monomer. Here's its hydroxyl group. If we want to build, say we're working with monosaccharides, so say this is glucose, this could be fructose, or it could be another glucose, whatever, just two different monomers of the same type, monomer. And we want to build something larger. So I'm going to link them together over here. This is what we get. Our hydroxyl groups have completely changed. We are left with just one oxygen. That means we removed a hydroxyl group from one monomer and a hydrogen from another monomer in order to link these together. Collectively, this hydroxyl group and this hydrogen, it's two hydrogens and one oxygen. We've essentially lost water. Minus H2, we have two of them and one oxygen. Because we're losing water, we call this type of reaction where we're building polymers from monomers a dehydration reaction. Because we're building something larger from smaller units, we can also call this a synthesis reaction. Which is also called an anabolic reaction. So basically a dehydration reaction like the one that we're doing if we're linking together monomers, that's an example of a synthesis and of an anabolic reaction. We can have other kinds of synthesis and anabolic reactions other than dehydration ones, but all of these, this and this, describe this dehydration reaction. Also, there's one other term that's required, or that's regarding energy, that we can be used to describe this type of reaction. And that's whether or not it's going to require energy input for it to proceed, or if it's going to release energy in order for it to proceed. Anytime we're linking smaller pieces and trying to build something, so if we were to take Legos and try to stick them together, that's going to take a lot of energy. So it does require an input of energy. So we call that an endergonic reaction, which means that it requires energy. And I'm just going to put E for energy. So if that's everything that describes building these polymers from monomers, the opposite is true if we want to break them down. So if we want to take this, even if it's just a disaccharide, and break it back down into its monomers, we're going to have to add everything we took away, so water, in order to get our monomers back. Because we have to add water, we call this type of reaction a hydrolysis reaction. And this is breaking down, so this is a decomposition instead of a synthesis reaction. And it's a catabolic reaction because we're breaking something down. Anytime we have something larger and we break off pieces of it, as we break it down, it releases energy. Sorry, I don't know why it keeps doing that. Anytime we release energy, it's called an exergonic reaction. So how do you not get these confused? Dehydration and hydrolysis. Think if you're eating food which has all of our big polymers or macromolecules, we want to drink water to help break them down into their monomers so that we can use them. So drink water to break things down, and that means it's a hydrolysis reaction. And that's it.